So with the basic skeleton we have here, we have the first idea of encapsulation, which is grouping. So we see that we have our attributes, our behaviors, the functionality, and the data, essentially. We haven't put it in there, but we have the idea of what's going to go in there. As we go along, we're going to talk about the idea of data hiding, and the second meaning of encapsulation, of course. So what we're going to do here is, using our basic structure here and our design of our class, we're just going to implement this as quickly as possible. So the first thing we see is we have image, rectangle, float, and a byte. These are the 4 pieces of information that we're going to be storing. Now, in a basic C# program, we don't have the idea of a rectangle or anything like that, so we can't just start using it. So we need to include another library to do that, which is system.drawing. Now this is only for the graphical items that we're going to be putting in here, like image and rectangle and whatnot. If you're building a class that has nothing to do with graphics, you would not need that data, or you would not need that library in any way, shape, or form. So it's just for this example. So as we see here, we're going to add our 4 pieces of information. So we have our image, which is going to be called image. We have our rectangle, we're going to call it bounds. We also have our y speed and our state. So our float y speed, and we have our byte state. And we're going to pause there for just 1 second. So looking at this, we have our 4 pieces of information. And what we want to do is we want to specify our encapsulation. We want to specify whether we want that data to be accessible or not accessible from other classes. What that means is if another class creates an instance of this class, so it wants to use a bomb, so for example our world would have a collection of bombs, a list or an array of bombs, does the world have access to see each individual piece of information? So we have to make that decision, private, public. Public means that as long as the other class has an instance of our class, it can access that piece of information or functionality. Private means that only this class itself has access to that information. There's another one that we will use later on, but we have to cover the next pillar first. So each of these private and public, they have a special name. They're called access modifiers. It really essentially modifies who or what has access to that data or action. So the image data, no external class is ever going to need access to that. So I can make this private, if I can spell. The bounds, some things may need access to it, but we want to have control over that. So we're going to encapsulate that data, and we'll decide who has access to that when they call for it, or any special circumstances we have to deal with. The y speed, again, this is going to be local data that's only going to be used in here, so we're going to make this private as well. And again, the state, we're going to keep this local as well. So this is all private, so all of our data is private. Now we have this state information, and it's byte, and it's a byte data. So what can we do for this? We need to figure out, well, what type of states can our bomb be in, and we decided it can be in 3 states: inactive, active, and exploding. So when we create a list of bombs or an array of bombs, of course they're not always on the screen at the same time, so they're probably going to start off probably in the inactive state. So just to simplify this, so I'm not using any magic numbers or anything like that, I'm going to create some constants. So let's say const byte, let's call it state inactive, and it's going to have the value 0, and we're going to have 2 more after this. One for active, which is going to have the value 1, and one for exploding, which is going to have the value 2. Alright, and we're going to give the initial state a value of inactive. Now you never see any 1s or 0s or 2s or anything like that. We have constants which represent something, and it makes it clearer to read. So the next step, which is really the most important step when we're building a class, is the constructor. So think of it like this. We discussed classes before, and we said classes are essentially a blueprint to something. Well, a blueprint needs somebody to build that blueprint and put it into action. In the real world, that might be like your standard house builders or whatnot, carpenters and whatnot. A constructor is kind of like that. The constructor says, this is how you actually create this object. So what it really does is it sets up all the basic data and calls any basic functionality that needs to be implemented when we create one new instance of that class. This is actually a subprogram. Particularly, it's a procedure. It doesn't return a value, but it's a very special procedure. It is the constructor. So it's created in a little bit of a different way. So to do this, we want external classes to have access to this. Otherwise, they'd never be able to create an instance of this class because they wouldn't know that it exists. So we have to make this functionality public. And then we simply have to specify the name of the class, bomb. So an external class, some other class, would be able to create a new bomb by just using the bomb data type. So bomb is now its own data type, essentially. And then we can open and close brackets, and it is actually functionality. So what we see here is what we call a default constructor. A default constructor is kind of like our basic form of a bomb. So if we specified no special data about it, this is what that bomb would look like. So for example, maybe we'll set the bounds up to a default value of the top left corner. Let's say 0, 0, and maybe 50 pixels by 50 pixels wide. And maybe that's the default size of a bomb. And its Y speed would have a default value of 0. And state is already inactive, so we don't need to specify that. But we could specify its image. Now, problem is we don't have an image to give it, so we're just going to specify a value of null. So this is a default constructor. So that means if another class were just to create a basic version of bomb, this is what they would get. It's probably not going to be used a whole lot, but there always is the chance, so it's not a bad idea to implement one of these. The other type of constructor is what we call an overloaded constructor. Overloaded means essentially it has the exact same name, but with different parameters inside the brackets. So this is where we can start to specify specifics about the bomb. So in the example or the analogy of the house, this might be where you specify the color of the house or the material of the driveway, that kind of stuff. In our bomb's case, what we're going to be specifying is the image that's going to be associated with the bomb and probably the boundaries. We're not going to specify the Y speed or the state because the Y speed may be randomly generated when we first drop it and may be based on what level the player is on or something like that. So it really shouldn't be part of creating a new bomb. And the state, as we see, is already specified to inactive when it's initially created. So now, inside of here, I can start specifying this data. So I want to set this global image variable equal to this local image variable. I can't just type image equals image. The problem with that is that the local variable named image overtakes or overrides the global version. So this is essentially setting this local variable equal to itself. So in order to fix this, we can specify and say this dot image equals image. The portion here where it says this dot, this references or this represents the current class that we're in. So since we're talking about the class and we have this dot, which essentially means ownership, the image variable, which is owned by this class, set that variable equal to the local image variable. Yes, this could easily be just avoided just by naming our image variable to another name, but I like to keep the same names just to be consistent. There's no point in renaming it something else, really. This is a simple fix or a simple addition, so there's no real confusion. And again, I'm going to do the same thing for the bounds. All I've done up to this point now is create my constructors and my attributes. Nothing really that special at this point. And then following this, we have our accessors and modifiers. The accessors and modifiers are our section of our code where we create access to data that we want available to external classes that's encapsulated. Right? So this all of our data that's encapsulated that we want other classes to have, we're going to create accessors and modifiers. Essentially, these are little subprograms to access the data or modify the data. And this is where we can add in that special code that says, you know, if you're moving and you're about to cross the boundaries, then don't do the actual move. For our basic data and intents and purposes, for what we're doing right here, we're not going to do that right now. We're just going to keep it simple. Sometimes accessors and modifiers are also called getters and setters, just to simplify the terminology. But it really means the same thing. Get the data or set the data. Simple as that. So again, because this is functionality built to give to another class, then this data needs to be public, right? So public means external classes can actually access this data, or access this functionality, sorry. So I'm going to create the accessors first. Public. Now access means I'm retrieving data, so it has to have a return type. This is going to be a function. So if I'm going to create access for, well, let's look at the data. What data do we want to be able to return? Well, we'll probably want to be able to return the bounds, not necessarily the image, because this class itself is going to handle its own drawing, so we don't never need to return the image. The speed, again, we shouldn't need to return that as well, so we're going to leave that alone. But we may need to be able to access the state from another class, because the world may need to know whether it should actually call the functionality on certain bombs or not. So if it's active or inactive, or whether it should be doing anything because it's currently animating or it's not animating, and that kind of stuff. So in order to actually handle this, we're going to create the functionality for the accessors of bounds. So we know it's going to return a rectangle, and we're going to say, okay, get bounds. Simple as that. It's not going to have any parameters. Again, if I want any special functionality here to decide whether somebody could access the data or whether that data is modified in any way on the return, I could do that right here with some if statements or some type of processing. But I'm just going to return bounds in this case. And I'm also going to do the same thing for state, the exact same idea. Public state is a byte. Get state. I'm going to call it a little bit more specific. Instead of get state, I'm going to call it get bomb state, just to be a little bit more specific. And again, it's not going to have any parameters. And inside of here, we're just going to return state. So our functionality is good, so we have our accessors done. Now our modifiers are going to be the exact same thing, except that instead of retrieving the data, we're assigning the data. So public, again, because they need to be accessible from external classes. We're not going to be returning any values, so it's always going to be void for our setters. So in this case, we're going to say set bounds. Now, if we're going to set the bounds, we may be setting them with a full rectangle. And we'll just call this new bounds. And inside of here, we're going to say bounds equals new bounds. And of course, we can do the same. We have to do the same thing with our. No, you know what? We're not going to be setting the state globally or externally, so we're not really going to need any functionality for that. So you can see we have two accessors, but we only have one modifier. The external classes should never be setting the state of the bomb. That should be handled within the class themselves. The only time you may want to reset all the states is if you, let's say at the beginning of a level or something like that. But that can be handled in any number of ways. For now, we're just going to leave it. And finally, all we have left is our behaviors. Now, if we go back to our other functionality, we have three behaviors that we got to deal with. We have update, we have draw, and we have start explosion. Now, because these are behaviors that are set up, some of them may need to be accessible from another class, some of them may not be. So for example, start explosion is probably only going to be used within the class. So it's probably going to occur as a result of a collision or something to that manner. So something may trigger that within our class. However, depending on how we do our collision detection, if we do it from the world may need to trigger that. So we're going to make that public, as well as the update and draw, because they're going to be needed from there as well. So we have our public void update, and for this code, I'm actually going to go back to here because I don't think we actually need the game time in this case. So we're just going to scratch this out because our bomb is not really going to need it here. They're just going to be, it's just going to update and modify on a very consistent basis. So we're not going to need any timing mechanism. So in here, we're going to simply do all of our code to update the bomb's location. We're not actually going to do that here, though. And then of course we have the same stuff for draw. Now this is going to require graphics context. In standard C#, that'd just be graphics. In XNA, that'd be a sprite batch. So I'm just going to say graphics G for now. And then we handle drawing code here. And then finally we have our start explosion. Oops. And it had no parameters. And blow up. So we've actually completed our class. Now, obviously, after we add in the functionality for this, for these behaviors, but as it is right now, we would be able to create and use our bombs as we need to. So that's what we're going to do in the next video: is actually implement these classes.